Okay, now now that we've worked on factoring, now the next step is to solve. But what I want to explain first is what the heck does that even mean when you're solving a quadratic? So let me show you visually what's happening. So a normal quadratic, say the parent graph looks like this, and it is a parabola. So if you put a 0 in for x, you're going to get a height. Well, I didn't necessarily draw that very well. It should have been more like this. Let me erase that. There we go. You're going to get a height of 0. So remember, this is y right here. When we're solving, we're finding the height of 0. So this 0 right here, this means the height of y. And what that tells us is if the height is 0, that's where the graph touches the x-axis. Where the graph touches the x-axis, that's the solution. So on a parent graph, where x is equal to 0, and because it's a quadratic, it only touches in one place, we'd actually say multiplicity of 2 because of this squared right here. So notice on the parent graph, y equals x squared, the graph comes down, it touches the x-axis at 0, and it goes back up. Okay, that's the parent graph. When you don't have the parent graph, and you have it in already factored form, what you want to know is, all right, where on the x-axis is that parabola going to touch? Well, there's this thing called the 0 property, and the 0 property says any number times 0 is equal to 0, or 0 times any number is equal to 0. All we did is reverse them, right? Well, what that means is if this parentheses is equal to 0, then 0 times the second parentheses will equal 0. So if we set this equal to 0, so we'd subtract 3 on both sides, we would have n is equal to negative 3. That would be one of the solutions. All right? And the graph is going to touch right there. Well, then we'd set the second set of parentheses equal to 0. So we'd add 3 to both sides. We're going to use the equality properties. So then we divide both sides by 5. So the next solution, so if this is 1, 3/5 might be about there. And notice in the solution brackets, I put them from least to greatest. And then halfway between this point and this point, those solutions, halfway, and you could add those two together and then divide by 2. I'm just going to kind of eyeball it. I don't know exactly where that's going to be. The graph is going to do something like this. The other thing that we know, this obviously is not to scale, but this 3 times negative 3, that's where it's going to touch the y-axis. Okay, so I've told you a lot of stuff. Now I'm going to show you an easier way. I've shown you the mathematically correct. You use the 0 property. And once you know the two values, these are the two solutions, also called, so they're also sometimes referred to as roots. They're also sometimes referred to as zeros. So if you hear any of those terms, it's talking about where that graph is going to touch that x-axis. If it's a y is equal to x. All right, or x squared or x cubed or whatever. Now let me show you this. A little bit easier way. is just say, okay, if we want this side here to be 0, what's the opposite of positive 3? Remember, because negative 3 plus positive 3 equals 0. So we can just take the opposite. The opposite of negative 3 is positive 3. The opposite or inverse of multiplying 5 is dividing 5. And then you just set it in the solution set brackets. And then you do your graph. I'm going to put the numbers out a little. Let me do this. Because sometimes the teacher is going to want you to graph it. So at negative 3, so if this is 1, 3/5 might be about there. And I know that the two constants multiplied is going to be where they touch. So way down here, that's more to scale right there. If I said that's negative 3, that's negative 6, maybe here is negative 9. And halfway between, let's see, add negative 3 plus 3/5, find the average, divide that by 2, so let me do that. Negative 3 plus 3/5, divide that by 2. And we get negative 6/5 or negative 1 1/5. Oh, I eyeballed that pretty well that first time. So there's your axis of symmetry. And then you're just going to graph. It's going to come down here. Oops. Probably going to do something like this. I don't know. That's kind of a plausible graph. Okay, so that is solving by factoring. So you would have to first factor if it's not already in factored form. So remember that little T chart, factors of C, so in this case 4, that have to add up to B or B. So factors of 4. This middle term is negative, so negative 4, negative 1, or negative 2, negative 2. Well, they have to add up to negative 5. These two don't. So we're going to have m subtract 4, m subtract 1, set it equal to 0. So the opposite of negative 4, m is equal to positive 4, m is equal to positive 1. I'll put them in order least to greatest. And then if I were to graph this, and we're going to touch on the y-axis at positive 4. So 1, 2, 3, 4. 1, 2, positive 4. And then halfway between 1 and 4 looks like is 2.5. So that's where the axis, that's where a parabola is split in half and it's symmetrical. All of these heights are going to be the exact same heights as on the other side. If you were to fold that over a piece of paper, both sides would lay right on top of each other. So we know it's going to touch here, we know it's going to touch here, and it's going to touch here. So one away from one away from, so that's going to be that height. And then halfway between, I don't know what it's going to be. We're not doing the vertex yet. I'm going to say maybe about there. Ta-da! All right. And I think, now, I will do this one. Oh, this one's an interesting one. In order to factor to find solutions, one side of the equal sign needs to be 0. And what you look at, as long as this is a positive variable squared, then you want to leave everything on this side. So we're going to add 4. We're going to put the right side equal to 0. But notice when we add 4 over here, So all we have is n squared subtract 5n. This is not a typical quadratic. There's only two terms. So this is when we do the reverse distributive. What do those two have in common? They each have a single n in common. So we're going to factor out an n. So n squared divide n. This cancels. That leaves n. 5n divide n. That cancels. That leaves subtract 5. Well, the opposite of negative 5 is 5. And just so you know, every time there is a number on the outside of parentheses and you're solving. So let's say it said 6n in parentheses. Let's say it said negative 7,000x outside of parentheses, or negative 7x squared on the outside. Every single time you've got a number attached to parentheses and they're saying to solve, that variable is going to equal 0. So this because look at, if this is 0, then 0 times that parentheses is 0. So it follows the 0 property. So now we have our list of solutions. And we know it's going to cross at 0 because negative 4 plus 4 is 0. So that happens to be one of our solutions. And let's call this 5. So halfway between is 2.5, or 2.5. So this graph is going to be doing something like this. And that's just kind of the general graph. All right, that is enough for solving. And the next one we're going to be doing is solving square root.